Yeah, just go ahead and share.
Okay.
And just a quick note, we're not doing chapters 4.5, 6, and like wherever the word problems are for multi systems of equations. We're just doing 4.1, 2, and 3.
Hi, everyone. We want to welcome you to this live stream. And Mr. Michael and I will be walking through a couple of questions. And we trust that as you participate, you should be able to learn a lot here. Thank you so much for joining. So in a moment, Mr. Michael will share his screen. So while he do that, I'll just play our live music as we welcome you in. All right, everyone, welcome back. Thank you for sticking around, and we'll begin shortly. Yeah, so Mr. Michael, I believe we're working through 4.1, 4.2, and 4.3, right?
Um, yeah, okay, yeah, thank you, Mr. Chinon. So I think in our last live stream, we started working on 3.1. So I think in today's class, we are going to be moving on to 3.2. I don't know, because we are already on inequality and we solved a couple of some of these questions here. I think we moved on to this is the last question in this section. So I think we should be moving on to 3.2 by the sequence of how we are moving. We'll be moving on to 3.2. Or do we have any change in plan?
Please go ahead.
Okay. Okay, so let me see if we completed the old questions here on 3.1. Possibly we can just do one more question section, and we can now just round it up and move on to 3.2. So maybe we can just take any of these questions here and we just round it up and move on to 3.2. Okay, maybe I'll take one. So today we're going to be starting this class today, the live stream today, with question 36. And I will do question 36, and after this problem, we'll now move on to the next section, which is 3.2. So we have 336 is about 3 in bracket, we have n plus 3 plus 7 in bracket, we have 8 minus 8n, and that is less than 5n plus 5 plus 2. Now we want to solve this inequality, and after we've solved the inequality, we want to graph the solution, and after we've graphed the solution, we want to now put our solution in interval notation. That's the instruction we had earlier in this particular practice problem. So to solving this problem, I think the very first thing we need to do is to expand. We need to distribute, or we need to remove the brackets, right? So we have to have 3 distribute into everybody in the parentheses. So 3 times n will be 3n, and 3 times 3 will be 9. 7 times 8 is 7 times 7 is 49. So 7 times 8 will be 56. So we have 7 times 8 again is negative 56. So we have negative 56n. And in the right hand side, we have 5n plus 7. So from this point, we can easily just do some combine the like terms, right? So, I mean, there are many ways you can even solve this problem. You mustn't follow the rules all the time. You can just go ahead and clean up the left-hand side and see if you can clean up any stuff in the right-hand side before you try switching these numbers. So from here, I can see I have 9 and 56 here, so I can just easily clean them up. So that would be 9 plus 56 is going to give us 65. And we have negative 56n less than 5n plus 7. So moving forward, we can now combine like terms. So we have 3n minus 56n less than, okay, sorry, we bring in the 5n from the right hand side to the left hand side. So that will become negative 5n. And we have 7 on the right hand side, and when we switch 65 to the other side, it becomes negative 65. All right, so I think everything is looking real good right now. So from here we have 3n minus 56, and that will give us minus 33 minus 53n, and minus 53n minus 5n will give us minus 58n, and that is less than 7 minus 65. That will give me 60 and 58, so negative 58. So all we need to do here is to just divide everybody by negative 58. Remember, when you divide both sides by a negative number, the inequality has to flip. I think we discussed this, the principles why the inequality has to flip in live stream yesterday. So when I divide both sides by negative 58, I'm going to have the inequality flipped. So I have negative 58 here, and that less than will turn over to greater than. And we have negative 58 over negative 58. So of course, these guys will cancel out. So we're just having n is greater than 1. So this is the solution for this inequality. And if you want to graph this inequality, that will just be, you put in the number line that depends on n, and somewhere around here is your 0, 1, 2, and so on, negative 1. So we go right on 1, and then every number greater than 1 is going to be to the right, right? So that is how it's going to be. If it is greater than or equal to, we then shade the circle. So this is the solution, and this is the graph. And lastly, we want to put it on the in an interval notation. So that will be like 1 comma infinity open. All right, so that is about this question for 3.1. So I'm sure if you don't have any doubt, we'll move on to 3.2. So over to you, Mr. Chinonso.
Thank you so much, Mr. Michael. Okay, I think we're moving on to the next set of questions, right? All right, thank you so much. So we have inequalities here, and in this case, we have compound inequalities. And for compound inequalities, there are basically two types. The one that has or, and the one that also has and. So in this case, I'm going to solve question 1, which is or. So we're having n all over 3 is less than or equal to -3, or -5n less than or equal to -10. Okay. So what we want to do is we want to solve and then plot the graph and then get the interval of the notation to know where the range of solution lie. So the first thing I want to first work on this part. So that's n is less than or equal to -n/3 less than or equal to -3. So I want to get the value of n, or the range of values of n. So to do that, I want to multiply both sides by 3 to make sure that n stands alone. So that would be n all over 3 multiplied by 3 less than or equal to -3 multiplied by 3. So these 3 cancels this 3. So that is n is less than or equal to -3 multiplied by 3, which is -9. So I have one of it. So it's either n is less than or, sorry, it's either n is less than or equal to 9, -9, or so I want to get the other range. So the other range is we have -5n is less than or equal to -10. So again, I want to isolate n, and remember in our last webinar, in our last live session, Mr. Michael explained to us how that when we operate with inequalities, when we operate with a negative sign, so either you multiply both sides by a negative number or divide through by a negative number, you flip the inequality sign. So to do this, what we want to do is to divide through by -5. -5. So this -5 cancels this. So I left with n. So we then have to flip the sign. So that becomes greater than or equal to. And then -10 divided by -5, which is 2. So we've got this, that means or n is greater than or equal to 2. So we want to go on to have its graph. So we want to graph this solution. So let me clean some part of, I hope I will get to it. Okay, I can use up here. All right, so we have at this point is 0, -1, -2, -3, -4, -5, -6, -7, -8, -9, and so on. And then we have 1, 2, and probably 3. So on the, now this is all, so it's going to be, remember we have 2 symbols. It's either you have your union or intersection point. So it's going to be union since it's all. So what we want to do is to get for the first part, which is n is less than or equal to -9, which is at this point. And then I have to take it this way. This is a shaded circle. And on the other hand, n is greater than or equal to 2. So that will be at this point. Okay, so having done this, this is the, what's it called now? The graphical representation. So I want to go on to get the interval notation to this particular question. So to do that, I just want to establish it using the interval notation. And in this case, I'm going to have -∞, and then comma -9. Now this is going to be this type. Then because it's or, I'm going to have union, and then this is also greater than or equal to, so I'm going to have a close bracket, this shape. Then I'm going to have 2 here, and then positive infinity. All right, so this is the solution to this particular question. This is where we have or, and so the other type is when we have and where we must have to have a common overlap, or where the two intervals overlap. Yeah, thank you so much. So Mr. Michael, over to you.
Yeah, thank you very much, Mr. Chinonso, for showing us how to solve compound inequalities. Again, the reason why it is called compound is because the combination of two or more inequalities. So that's why it's called compound. The 3.1 we did earlier was just simple inequalities. And now we are talking about compound inequalities, just like combination of two or more inequalities. And Mr. Chinonso have also made us understand that when we have or, it's also the same as union. And when we have and, it is the same as intersection. So he has already helped us solve question 1, and that depends on or. And so I'll look for one that has and. Okay, I'll look for one that has and. So let me do question 9. Yeah, we see some other questions with and, but the one he solved is more like a fraction. So this is like that one. So I'll do this one, question 9. I mean, if you understand this concept, if you've been following through our live stream, solving any of this problem would not be a problem for you. So let's do question 9. Question 9, we have -8 plus b, and that is less than -3. And so we want to solve them independently. Then once we are done solving this one, we'll now go on to the next one, which is this one. So let's quickly solve this one. So first thing we need to do is to isolate b on the left-hand side. So we add 8 to both sides of the inequality. And when you do that, you get b is less than 5. So we have one solution, b is less than 5. Now the second one is going to be 4b is less than 20, right? So we're dividing both sides by 4. And because we're dividing both sides by a positive number, we don't have to worry about flipping the inequality because it will not flip, it will not change. So we have 20 divided by 4, that is going to be 5. So what am I having here? I'm having the same solution happening twice. I really don't want this kind of scenario, but no problem, it's fine. Let's just go ahead and graph it, it's fine. So let me see if everything is right. Okay, everything is right. Yeah, everything is right. Everything is right. Okay, so let's go ahead and graph it. So b less than 5 and b less than 5 is just what they call it now. It's just like something happening twice, right? So we can just go ahead and sketch the inequality. Okay, so we sketch the inequality. So we have this inequality depends on b, and somewhere around here can be 0, 1, 2, 3, 4, 5, 6, and so on. And to the left is the negative integers, right? So we want to sketch b less than 5, so we go right on 5 here, and we open the circle. We are not going to shade it because it is just less than. So less than 5 means every number less than 5 is 4, 3, 2, 1, like that. So this is the direction of those numbers that are less than 5. So this is how the graph is going to be for the inequality. Because the inequalities are the same, so one of these sketch can just go for the both of them. Yeah, they can just go. The one of the sketch can go for the both of them. And lastly, we now write the interval notation. That would be +5 going over to the negative infinity. So that is how the interval notation would going to be like. Yeah, over to you, Mr. Chinonso.
Yeah, thank you so much, Mr. Michael. This is quite interesting. I think we can move on to the next set of questions. Or would you prefer we have one more or two more here?
Yeah, I think we've just covered the ones with or and the ones with and. Is just looking, is not looking so nice that we do not have a set of two inequalities where we need to show them what and really looks like. But I think it's all good. So what I feel we should do from here is we can now move on to doing those inequality that is more like a combination, like question 13 and question 14. Let me see. Yeah, question 13 and maybe question 22, just for more insights. So we can just do 13 and 14. I mean 13 and 22, just for more insight. But maybe if you don't mind, you can do any one that has to do with and. If you don't mind, if you want to show them how to utilize the word and maybe somehow I can do the other ones and we just move on.
All right, thank you so much. So let me just work on question 8, which you had already spoke about. So in this case, we have is also a compound inequality, and we have negative 9x less than 63, and x divided by 4 is less than 1. And so we again want to form the compound inequality. We want to have the graph. So first we want to work on this part of it. So that's negative 9x is less than 63. So to solve this, what I want to do is I want to divide through by negative 9. So negative 9, so I'm left with x, and then I flip this inequality sign. So that's 63 divided by 9. That should be 6. Negative 6. Am I right?
That is 7.
Sorry.
Negative 7.
Mhm. Okay, so we've got negative 7. So that is on the one hand. So I want to go on to the other side, which is x all over 4 is less than 1. So again, I want to get the value of x. So to do that, I want to multiply through by 4. I want to multiply the left-hand side by 4 and then the right-hand side by 4. So that gives me, this cancels this, so I'm left with x is less than 4. So I want to go on to plot this on the like the graph. So the highest number I've got here is 4. So this can be 1, 2, 3, and 4. And then the lowest negative number I've got is negative 7. So that's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7. So for the very first one, it's x is greater than 7, negative 7. So it's going to go anything towards this direction to infinity. Remember, we have our here. So this goes. And then for the other one, it is x is less than 4. So at this point, x is less than 4. So the solution is just the part where they intercept. So it's just from this point. So if I want to have the interval notation, it's going to be on this side, negative 7, comma, and then the maximum one. Remember, this is okay. Just a minute. Okay, so this is negative 7 and then comma 4 on the other side. So this interval is what satisfies this. And then because it's intersection, so I want to get where the two inequalities intersect, and that region is the only solution to this compound inequality. Yeah, so thank you so much. So Mr. Michael, over to you again.
Thank you so much, Mr. Chimasu, for helping us understand how to utilize and inequality. So I think I'm going to do question 13, which is quite different from the ones we've been solving earlier. And you can see question 13 is having the less than, and question 20 is having 22 is having the greater than. So I'll just do one or two of them and then we'll move on. So question 13, we have 3 is less than or equal to 9 plus x and less than or equal to 7. So we want to divide and solve the inequality, and once we are done with solving the inequality graph, we now write the interval notation. So the idea is we want to make sure that the central point of this inequality is just x. That's the idea. We want to get rid of everything in this central point so that we just have only x by itself there. So if you observe, you can see we have 9 there. So we really want to get rid of 9 from that central position. So how do we get rid of 9 from the central position? We subtract 9 from both sides. I mean, from every side. Okay, you can see we have more than 2 sides here. These are like 3 sides. So subtract 9 from every side. And let's see what that would be. So 3 minus 9 would be minus 6. And so we have less than or equal to 9 minus 9 is 0. So these guys cancel out. So we just have x right here. And we now have 7 minus 9, which is minus 2. So we are done. I mean, this is just the inequality. We are done. We are done with the inequality. So usually, you can still go ahead and split up this inequality, like saying negative 6 less than or equal to x, and you have you now have you cannot rewrite this stuff as, you know, I like to tell you to make the x come first, so you cannot rewrite this stuff as x is greater than or equal to negative 6, right? And then the second inequality is this one, where we have x is less than or equal to negative 2. I mean, you can just work with this one here. I'm just trying to show you that this inequality, you can also split them. Some persons might not solve this problem the way I'm solving it. Some persons might solve this problem by splitting the inequality at the central inequality to both ends. You still get the same result. So now we have the solutions to that inequality. We just graph them. Okay, let's say somewhere here is 1, somewhere here is 0, here is minus 2, somewhere here is minus 4, somewhere here is minus 6. I understand you're wondering why I'm having these numbers like this, just because for simplicity, okay? So you can just run the 1, 2, 3 and the rest of them, or put the scale you're using. So let's graph this stuff. X is greater than or equal to negative 6. So I'll come to negative 6. Of course, I want to shade it because it is greater than or equal to, so it's moving in this direction. And you can see x is less than or equal to negative 2. So I'll come right on negative 2. And if I sketch that, because it's less than or equal to, it's moving down the line. You can see they both have intersection. All right, so they both have intersection. And take note, they are both inclusive at both ends. So extremely, these two numbers are part of the solution, the minus 6 and the minus 2. So how do we then put this stuff in interval notation? We use minus 6, comma, minus 2. And take note of the bracket I'm using. That's the close bracket, the enclosure bracket. All right, so that is about that question for question 13. And I'm sure if you understand the whole of that concept, you should be able to do every other question in that manner. Yeah, I think so. So, but if you have questions, joining us on YouTube, kindly go ahead and put your comment on this on the comment section, your question on the comment section. Of course, we keep our eyes on the comment section. If we see questions there, we can bring it up on the live stream. And you want to subscribe to this channel, you want to also share this video link to other learners. That is one way to appreciate what we are doing. Tell other people who are still in school, who may find value from this video, tell them what we are doing on YouTube every day, same time, same station. Tell them what we are doing. That is one way to appreciate the work, and we really do appreciate that. So thank you so much. Over to you, Mr. Chinonso.
Yeah, thank you so much, Mr. Michael. So I think we can move on to the next set of questions.
Yeah, so let's slide on to the next section. All right, so we are done with 3.2. That was very fast. So we are on to 3.3. So let's quickly move on to the questions we have on 3.3. I think this is even the last section in chapter 3. So I think once we are done with this absolute value, that will be all for that will be all for chapter 3. And we'll just move on to chapter 4. Okay, so here comes chapter 3. Let me see if we still have, okay. Yeah, you see, once we are done with this section now, we on to chapter 4. So let's see what we can do here. Chapter 3. All right. 3.3, I mean.
All right. Yeah, thank you so much. So this is absolute value inequalities, and it's peculiar and very easy to solve. So when you have an absolute value, say absolute value of A, there are two possible values of A. So it's positive A or negative A. So that's just the basic principle, and that's what we'll be applying here. And so when we apply that for each of the absolute values, then we can get two values of X two range of values, and then we can go ahead to plot it on the graph to see if we get a situation where it overlaps or no overlapping at all. So to do that, let me solve. Well, question one is like the easiest and the most basic, but again, we have to start from somewhere. So we've got absolute value of x is less than 3. So to solve this, like I said earlier, when you have absolute value of a, it is possible that a is a positive number or is the negative part of it. So to do this, we have two values of x, possible values of x. First is the positive one, so we have x is less than 3. And if that is the case, what we're saying is that x is less than 3. It's also possible for us to have the negative one, which is negative x. Remember, let me just have it here, or x, negative x is less than 3. So we can go on to solve this second part because we are looking for the value of x, not negative x. So to do that, we want to divide through this by -1. So once we do that, this negative cancel. So we're left with x, and then we flip the sign, so it becomes greater than 3. So given this, we can then have a situation where, sorry, this is -3. So we can then have a situation where, remember, if I know Mr. Michael explained something to us that if x is greater than -3, if I want to flip this -3 to the others to the left-hand side, it becomes 3, and then I flip -3 and I flip the sign to be less than x. Okay, so having said that, I can form a compound inequality from this absolute inequality where I would say -3 is less than x, and then this same x is also less than 3. Remember, we will have it here from the first statement. So less than 3. So we can go on to plot the graph on the number line. So this is 0, we've got 1, we've got 2, we've got 3, we've got -1, -2, and -3. So we can then follow this. So x should be a number that is between, so x should be less than 3. So if this is well, I think I'm trying to. So let me leave it how it was. So we've got x is greater than -3, and we also had x being less than 3. So let's have that. So x is less than 3 gives us this, and then x being greater than -3 gives us this. So it means that this is the range. This is the graph anyway. So we can now have the interval. And then the interval will be, so at this point, we'll have -3, 3. So anything within this interval satisfies this particular inequality. Now, what would have happened was if we had absolute value of x was greater than 3, probably what I was trying to explain would have hold. But in this case, it did not hold because as I tried to plot this, well, this statement is still correct, but for the purpose of plotting the graph, I don't think I need it. Yeah, so this is the solution. Thank you so much, Mr. Michael. Over to you.
Yeah, thank you very much, Mr. Chinonso, for that particular question. Like you said, that is more like the foundation to understanding absolute value. And now we understand the foundation, I think it now makes sense for us to move a little bit a step further to solving more problems on absolute value. Now, just before we start solving, 1 second. Okay, let's do question 5. Let's do question 5. So question 5, we are having absolute value of x minus 2, and that is less than 6, right? Now, just like Mr. Chinonso earlier explained, the absolute value here, the content of the absolute value can either be positive or negative. So we can take advantage of that condition and develop two inequality. Okay, the good thing is I'm going to try to solve this problem in just 2 ways, but let me do this one. Let me do this one method. Maybe if there is time, or maybe if Mr. Chinonso will not show us this other method, I might do something like that. So this method I want to show us right now is this. For us to remove this absolute value, it's going to be x minus 2 less than 6, okay, and then greater than minus 6. That's another way to excuse the absolute value. Okay, so once you're able to do that, you now have these compound inequalities, and you already see how we solved this problem before in the previous section. So what we need to do is to add 2 to every side to get rid of the -2 in the central position, so that we just have all x by itself in the central position. So when we do that, we'll be having -4 here, and we'll be having x here, and we're having 8 right here. So now we have the solution to the inequality. And again, you can just go ahead and sketch this inequality that depends on x. And I can just say somewhere here is 0, and somewhere here is negative. Oh, sorry, my pen. Yeah, I think somewhere here is -4, and somewhere around here is +8. So when I come to -4, and I'll go to -8. When you have this kind of inequality like this, I mean, the less than, it's just talking about range. Okay, so you can just go ahead and sketch it all by all what I'm doing right now. I mean, all by what I'm doing right now. So when you have the less than like this, it just try to tell you that x is between -4 and -8, just like Mr. Chinonso have explained. So having understood that, my inequality is going to be between -4 and +8. And I don't need to shade the inequality because this inequality is just only less than and not less than or equal to. So this is the graph of my solution, and finally I'll put it in interval notation to be -4 comma +8. Yeah, thank you very much, Mr. Chinonso. Over to you.
Yeah, thank you so much, Mr. Michael. I think we can take one more here and we can probably take a wrap here. Can we scroll a bit? Let me see if I can get something different, slightly different. Okay, let me work on 18. 18 will do. Okay, so question 18 here we've got 2x, absolute value of 2x minus 4 is greater than 6. So again, we want to emphasize the fact that when you have absolute value, you want to take both the positive and negative value. So we'll first take the positive value here, which is 2x minus 4 being greater than 6. And then to get the value of, so I want to isolate 2x, so I'm going to add 4 to both sides. So 4 and 4. So I'm left with 2x is greater than, sorry, so 2x greater than 10. So to get x, I need to divide through by 2. So that my x, this is 2, so that x is greater than 5. So this is one of it. So the case 2, thank you so much. So case 2 is the negative side of things, which is negative value of 2x minus 4, which is greater than 6. So I need to distribute this negative sign. So that's because it's like a -1 here. So that becomes -2x plus 4 is greater than 6. And then to isolate the term with the unknown, I want to subtract 4 from both sides. So I'm left with -2x is greater than 2. And then I can go on to divide through by -2. Remember, when we divide through an inequality by a negative number, we flip the inequality sign, or even if we multiply by a negative number. So, so what I'm left with is x is less than -1. So I've gotten the so I'm trying to even see where to write that, to draw the graph. Okay, let me use here. So we've got +5. So I'm going to have this as 0. We've got 1, we've got 2, we've got 3, we've got 4 and 5. And on the other side, we've got -1 and -2. So these are the two. Thank you so much, Mr. Michael. So we got x is less than -1. So which is at this point, x is less than -1 to infinity, negative infinity. And then on the other side, we've got x is greater than 5. So this goes to a positive infinity. So to write the interval, the interval here definitely would be negative infinity, comma, now -1. Now, since they don't have any common point, union is what is going to bind them. So it's going to be or. So it's going to be, the solution is going to be either this range, anything around this range, or anything around this range. So I'm going to use the union symbol, not intersection. And then on this other side is going to be 5, of course, +5, then comma, infinity here. So this is the interval notation, and this is the graphical notation of question 18. So let's explain. Yeah, so thank you so much, everyone. Please feel free to drop your questions or comments or observation in the comments or chat feature, and we'll be keeping an eye to ensure we respond to you accordingly. And you can always visit the link in the bio of this video and reach out to us, visit our website, follow our social media handles, and we'll always keep you updated with math problems, solving math problems. Thank you so much. Over to you, Mr. Michael.
Yeah, thank you very much, Mr. Chinoso, for showing us how to solve this problem using the cases, case 1 and case 2. Okay, so I think we need to do a problem where we do not have a clean look of the absolute value. I think this one is looking clean. I think we need to do a problem like 26, 28, or 30, so that our students get to see how to solve problems in that manner. So I will just take one of these problems. Maybe I'll take question, which one now do I take? I'll take question 26, right? Let's do 26. Okay, so 26 we have, this is question 26. We have -3, -2, and we have absolute value. In absolute value, we have 4x minus 5. And we have it to be greater than or equal to 1. Yeah, I think that is the right question. Yes, perfect. So I think one of the wrong way of solving this problem, what some students will do, I won't say most students, because I feel I just want to be positive, okay? So -3, -2, if a student would have solved this problem as -5, and then they start writing the absolute value, that would be wrong, because you cannot do subtraction before multiplication. Okay, the absolute value here is just like a parenthesis, so you don't want to do subtraction before multiplication. In fact, the relationship between these two and the absolute value is multiplication. So doing -3 minus 2 is wrong. Okay, that is just one way of solving it wrongly. Now, so how do I even start solving this problem? First thing, I need to get rid of -3 here from this left hand side. I need to switch it over to the right hand side. So that's going to become -2 absolute value of 4x minus 5, and that is all greater than or equal to 1 plus 3. You know, when you switch -3 to the other side of the equation, it becomes +3, right? So now we have a -2 absolute value of 4x minus 5 is greater than or equal to 4. So at this point now, just like when you have -2x is equal to 4, you want to divide everybody by -2, right? So that is exactly what we are going to do here. We'll divide everybody by -2, but remember that you're dividing both sides by a negative number. You have to flip the inequality from greater than or equal to less than or equal to. So why we are doing this is so that this coefficient here will cancel out, and now we'll be having absolute value of 4x minus 5 all by itself, and here we'll be having -2. Okay, so this is the idea. This is now where this is the point where you get to and you begin to solve. This is the point where you get to and you begin to solve. But I think there's something we did not discuss earlier, right? There's something we did not discuss earlier, which is absolute value cannot give us a negative result. Absolute value cannot give us a negative result. So we cannot have something like absolute value of 3x plus 4 is equal to -5. We cannot have this kind of scenario because absolute value cannot give us a negative result. So this is for equality signs, right? This is for equality signs. So when we have equality, we cannot have a negative result for the absolute value here. But when we have inequality, Does it work? When we have inequality here, absolute value of inequality give us a negative result. Does it work? Okay. Okay. Just if we are not sure, I think we can just go ahead and solve the problem and test run the answer. But I'll just go ahead and call this equation star because um when we have this kind of scenario where we have absolute value of a quantity equal to negative result, there is no solution for that. There's no solution. The reason is that absolute value always absorbs the negative and gives us positive. So you cannot produce a negative result. So here, I still would say that it will not give us, this will not have a solution. This problem should not have a solution. But let's go ahead and solve it and see if it will have a solution or not. Let's go ahead and solve. But I feel this problem will not have a solution because it's a negative result. But let's solve it and see what the outcome will be. So we have 4x minus 5 less than or equal to negative 2 and greater than or equal to 2. Okay, you see, there will not be any solution here. So what do you think? I don't think there will be any solution in this case. Or should we go ahead
Yeah. No, I don't think, like you said, there is no solution. The reason being that absolute value can, like you mentioned, cannot give us a negative. So I think this question is put there intentionally to see how our students can, crack their brain and test their understanding.
Yeah. So I think having a negative result here defies what absolute value really stands for. Because a good guy, it cannot give you a negative outcome. So having this kind of solution, you can just say no solution for this absolute value. And the reason is because of this result, negative 2 we have here. So I was thinking we are going to get, but I hope you guys understand what we did. So you can go ahead and solve 28, which is almost like 26. You want to clean up everybody here before you start applying the absolute value principle, split them into two inequalities. So that is exactly what I was doing. I have to make sure I clean up all the quantity just before the absolute value. And when I now done the cleanup, I got the absolute value all by itself. Then I can now go further to start solving the absolute value by applying the principles of absolute value. And in this case, it's a case where we have no solution because of the result we have. So that is that for that particular question. I think at this point, we can confidently say that we are done with solving questions on the absolute value inequality. This is absolute value inequality. Maybe in the future, we still go into the absolute value equations too. So Mr. Chinonso, over to you. You want to say anything concerning this before we move on to the next section?
Yeah, I think we are good.
Okay, perfect. All right, so we are just done with chapter 3, and we are now moving on to chapter 4. All right. So here comes chapter 4, and I think let's go ahead and check if there's any chats on the comment section before we move on to chapter 4. Let's see if we have reactions of our viewers watching. Okay, I think we are still good to go. So let's just go ahead and move on to chapter 4. So very quickly, these are the objective for chapter 4. So we're going to learn. Chapter 4 is about solving systems of equation, right? And these are the contents of what the system of equation will be like. We will learn how to graph the system of equation. We'll learn how to solve by substitution method, elimination method, and we also move on to solving 3 variables that has to do with systems of equation, and then the application and mixed problem. So let's go to 4.1, which is the graphing section. Okay.
So I'm wondering how we'll solve this 4.1 given that we have to graph. So we'll try to have a graph sheet with equal cells.
Yeah, I think we might need to design a graph sheet so that whenever we have scenarios like this, we can just
Yeah.
graph sheet and use it to work on the problem. Yeah.
Yeah, because looking at this, we have to graph and then use the graph to get the solution. And we want to be accurate to get the point of intersection. But anyway, I think we can try our best. We can try our best.
Yes.
Well, in
Yes.
other words,
Yes.
to explain the concept to students so that when they have the graph sheets in front of them, they can get the answers.
Yes. Yes. Yeah, that will be fine. And also, those students who are preparing for the SAT can also go ahead and try this stuff using the Dexmos
Yeah.
calculator.
Yeah, and of course the Desmos calculator is embedded in the Blue Book app.
Yeah.
So in fact this is like a walkover for students. But for the purpose of explaining, I think we can just take one and then use that one to explain how to graph. The reason is we can only make approximations and then except we have a graph sheet, a clean graph sheet. Now, say for example, I have my line is not straight. So I'm wondering how, so let's say I'm going to try my best to make sure they have equal distance. Okay. So -1, -2, -3, -4. 1, 2, 3, 4, 5. The same thing on the y-axis. So 1, 2, 3, 4, 5, 6. And then -1, -2, -3, -4, and so on. So, for example, if we want to plot the first line, so this is y is equal to -1, negative x plus 1. We already know that the slope here is -1. Yeah, so Mr. Michael, would you want to now I'm trying to be careful here so we don't plot it wrongly.
Yeah, it's good. It's good. No problem. Your graph is even looking almost perfect. I mean, it's okay. So maybe we can just go ahead and do a rough sketch, and our students they are going to understand what graphing equations is all about. So we can just do a
Okay.
rough.
Okay, you want to do that? Please go ahead. Feel free.
Okay, okay, fine. Yeah, so let's graph these equations one after the other. So you can see we are working, let's work with what number do we work with now? Let's work with question 1. Let's start with the very first question here. I would have wanted to do question 3, but it's no problem. Let's do question 1. Question 3 is quite easy because of this line. It's very easy to graph horizontal line. I mean, it's almost perfect. But because of let's just start with the first question here on this section. So question 1, we have this equation. We have y equal to -x plus 1. And so, I mean, there are many ways we can do the graphing, right? We graph them independently. So this is our first line, and this is our second line. So we graph them independently. Once we are done with this first line, we then graph the second one. So because of because of because we don't have a graph sheet here, okay? So let's just use the y-intercept and the x-intercept to get the 2 points, and then you draw the line, okay? If that makes sense. So looking at this problem, you already know that when you compare this problem to the general model of a straight line, you can see that the y-intercept is 1. I mean, y-intercept is the point where the line is cutting the y-axis, so that is 1. So I'll just come here and mark point 1. You can see the point 1. So that is 1 point. So we just need another point and we draw that line. So the other point now is getting the x-axis, right? I mean the x-intercept. We just gotten the y-intercept, right? Now let's get the x-intercept. So how do we get the x-intercept? It's simply when y is 0. It's simply when y is 0. So when y is 0, that's going to be 0 equal to -x plus 1. And when you switch -x to the left-hand side, so that becomes x is equal to 1. And you see, x is equal to 1. the x-intercept when x is equal to 1 is this. This is the x-intercept where x is equal to 1. This is the point where x is equal to 1. This is the x-intercept, right? So this is in coordinate, this is just like 0, 1, okay? So when, sorry, not 0, 1, I mean 1, 0. Yeah, 1, 0, because we already said the x-intercept is gotten when y is 0. So, and that is this point. This is the point right here. So I need a ruler now to join these two together. I think in our next class, we are going to prepare for graphing. We might have all the
Okay.
tools.
Yeah.
We'll prepare for graphing. So learners watching.
Wow, but this is a perfect line. It appears as though you use the ruler.
Yeah.
So I was scared of these tasks. That was why I threw it back on you.
No problem. Yeah. Like I know I told you I'm a very good artist. Remember I told you, right?
Yeah, it's evident.
All right, so let's graph the second line, which is y equal to negative 5x minus 3. So all we need to do here, of course, you can see when you compare this with the general form of a straight line, you can see the y-intercept is negative 3. So we have one point, which is this point here, and that is the y-intercept, right? So let's quickly get the x-intercept and we connect the two lines. And what did we say about the x-intercept? You get the x-intercept when y is 0. So when you plug y to be 0 in this equation, you get 0 equal to negative 5x negative 3, right? And when you switch this negative 5x to the other side, it becomes 5x equal to 3. Equal to negative 3. And you want to divide everybody by 5, like this, or this is not looking nice. So, and my pen is kind of working by itself. Sorry. I think I need to reset what they call the pressure of this pen. So when you divide everybody by 5, you get x is equal to negative 3 upon 5. So I would like to put that in decimal so that I'll know where that really falls in. So that would be negative 0.6 if I'm correct, right? Yeah, if I'm correct. So if I have an integer, that would have been better, but decimal, let's just manage decimal. Negative 0.6 will be somewhere around here. Somewhere around here. Just from 0 to negative 1. That'll be somewhere around here. Okay, so guys, you can just manage this stuff. And when you now draw these two lines together, this time is not looking good, but we'll just see how we manage these two lines. Okay, and we'll just see how we can manage these two lines over here. All right, so guys, I just hope you understand what we are doing here. Maybe this might be the last question for this section, so that in our next class, we are going to prepare with the graph tools and all those tools for this particular section. But if you've been following what we are doing, you can go ahead and replicate the same thing on your graph book, and I'm sure you're going to get the same answer. And if you have the Dexmos, you can go ahead and try doing this stuff with Dexmos. And finally, the solution is simply the point where the two lines intersect. Mr. Chinoso already explained the cases of lines, sketching or graphing lines, where we have unique solution, no solution, and infinitely many solutions. So this is the case where we have a unique solution because the lines intersect, and this is the point of intersection. So that would be somewhere approximately 2 on approximately negative 1 on the x, and approximately negative 2, approximately 2, sorry, on the y. So somewhere around here might be the solution, approximately. But this is, I'm sure this is not the solution, but approximately this is the solution because we don't use a proper sketching tool. So I think it's good. Mr. Chinoso, over to you.
Yeah, thank you so much, Mr. Michael. I think you did great justice to this question. Beyond my expectation. And I wouldn't be surprised if the actual answer would be negative 1,2 when graphed on the Desmos. The reason why we are not able to give it that with precision is we have not used the graphing sheet here, so it's just approximation. But I believe that the students have been able to understand the procedure and the steps in answering this kind of question. Yeah, so thank you so much, Mr. Michael. I think we can move to the next set of questions.
Okay. 1 minute, sir.
All right. All right, yeah. So, Mr. Merkel, I'm glad that we've been able to stop at this point, and most likely in our next episode, we'll have a graphing sheet to maybe take more questions with precision, right?
Yeah,
So,
yeah,
I
yeah.
think we can wrap it up here and prepare for the next set of questions in our next stream. And so I want to encourage our participants on YouTube and all the platforms to please follow, make sure you subscribe to our channel, turn on the notification button, and we create this kind of videos. We want to make math fun. We'll be solving problems live, and you can always ask questions using the comment section, and we'll respond to you. You can know more about us by visiting the links in the bio of this video, and we're more than happy to make sure you meet your mathematical expectations and goals. Thank you so much. So, Mr. Michael, any final words from you as we close?
Yeah, I have a final word and a good news. Guess what? The answer we got, -1,2, is the correct answer. I just used the Dexmos now to confirm
Yeah,
it.
I knew. I told
Uh,
you, don't be surprised. The reason is it was so close. It shows that you have some precision in your hand. Well done.
I just quickly
Interesting.
use the Desmos to confirm it and see if what you said is true, and that is really true. The answer is just -1,2. That's the point where the two lines intersect. I mean, it's so interesting to use a freehand sketch to get these answers correctly. I mean, so students, you don't have any excuse. I mean, not to try and not to do well. So you can do well. You can try all of these things we've discussed here with your graphing materials, or you can use the internet. There are so many tools. You can use the internet, so many tools online that you can use to graph equations and straight line. But I'll prefer you get the graphing tool, the graphing material, and sketch this thing all by yourself. Understand the manual before you start doing using simulations like the Dexmos graph calculator. So once again, thank you so much for watching, and thank you so much for staying to this very point in time. You are the real gem. We appreciate you. And just for you to appreciate what we are doing, kindly go ahead and share this link to other learners, to other school platforms. We are just here to help you scale your math education. We want to bring you up to speed so that you can relate properly with what is happening in your school. So we are here to make you better. That's just the short story of what we are doing here. We're here to get you better, get you set for calculus. So guys, that will be all from my end. Mr. Chinoso, if you have anything to add to it, that will be a bye-bye from
Yeah.
my end.
All right. Thank you so much, Mr. Michael, and thank you to all our viewers and participants. We look forward to seeing